Unity is a development engine used to create 2D and 3D video games, cinematics, vehicle and architectural concepts, and more. It's the engine behind popular titles like Escape from Tarkov, Cuphead, Hollow Knight, and countless other indie games across consoles, PCs, mobile phones, and virtual reality platforms. Unity has been around since 2005 and works on Mac, Windows, and Linux. If you already have Unity installed and know how to use the Unity Hub, feel free to skip ahead to the timestamp on your screen, but if you're brand new to game development and don't know where to start, then stick with me for a bit. You might be thinking, dang, I'd like to make a couple games, but my computer's a little tater-tot. You can actually run the Unity game engine on a fairly powerful, low-budget computer. The minimum system requirements say you can run Unity on a PC with Windows 7 or a Mac running macOS Mojave. However, I wouldn't recommend using such outdated operating systems. For you non-tech savvy people who don't care about details, I'd say you'd be fine using any PC with a graphics card from 2016 onwards to get you started, though this is the minimum for a decent game development experience. For more technical people, I'd recommend the oldest operating system you can use as Windows 10 for Windows platforms and macOS Monterey for Macs. For CPUs, a Ryzen 3 or older Intel i5 is enough to get you started, though a Ryzen 5 or newer generation Intel i5 or i3 will be better for more graphically demanding projects on a budget. For GPUs, if you're on a really tight budget, a 1050 or 1050 Ti can get you started, though a 60 series graphics card like the 1060, 2060, 3060 or even 4060 will carry you through game projects with higher fidelity, better lighting, detailed shadows, etc. If you're part of Team Red, then the equivalent of the aforementioned GPUs should work just as well. As far as RAM goes, 8GB is on the lower end, but if it's all you have, you can get by. You'll just need to make sure everything else but the Unity game engine is running, and you might experience some slowness based on how complex your project is. For beginners who want to get their feet wet, it'll do. But just for now, 16GB gives you more breathing room, so once you start getting the hang of things, you should upgrade to that. As far as storage is concerned, the Unity game engine size will grow or shrink depending on how many extra models you want, such as if you need additional tools for mobile game development, WebGL support, etc. I'd recommend having 15 to 20GB of free space on an SSD to install the engine and a further 20GB to store your projects to begin with. The more projects you have, the more space you'll need. The other parts such as the power supply, motherboard type, mouse or keyboard don't have a major impact, so you can use what works best with your computer. The only extra hardware you might need will depend on what platform you're building for. If your game supports controllers, you'll need a controller to test the controls. The same goes for Android and iPhones for testing mobile games, VR headsets for VR games, and so on. You can download Unity for free from unity.com. You may also need to create a Unity account before you get started, but that's also a simple and free process. After creating an account, you can select either the student plan if you're a 16-year-old and above high school student or in college, or you can use the personal plan. These are the free plans Unity offers. However, the student plan has some added benefits such as discounts on assets and licenses. There are multiple Unity versions available, some of which are older to support older projects, while others are experimental to test new features. Regardless of which you choose, you'll first need to download the Unity Hub to manage all your projects, installed modules, Unity accounts, etc. Another program usually installed with Unity is a code editor called Visual Studio. This is where you write all the code meant for the game, but we'll talk about that later. It's usually a good idea to install the latest stable version of Unity because the others are often still experimental or may have outdated features. The stable versions of Unity have the letters LTS next to them, which stands for long-term support. If you want to know the latest one, you can visit the Unity docs on docs.unity3d.com, whose landing page often shows it. You could also search online for the latest LTS Unity version or visit the Unity release archives to see all the current, previous, and experimental Unity versions. Once downloaded, this is where you manage all your projects, Unity accounts, installed modules, and editor versions. Go ahead and sign in with your Unity account if you have one, or create a new one if you don't. After signing in, you might be prompted to agree to the Unity license before doing anything, so go ahead and do just that. Your account will appear at the top left of the sidebar, and clicking the arrow next to it reveals all the necessary information associated with your account, such as account settings, troubleshooting, and the option to sign out if you want. If you want to change your Unity Hub preferences, such as switching from light mode to dark mode, or you want to view all your licenses, install locations, and more, you can do so by clicking the cog at the top of the sidebar. The Projects tab is where you'll find all your Unity projects. You can organize them based on when they were last modified, and each project has information such as the Unity editor version used, if the project is connected to the Unity cloud, or if the project uses Unity version control. The Install tab is where you'll find all your installed Unity versions. You can view all the official releases you have installed or the pre-release versions. Don't worry about pre-release versions because you don't need them now. You can add modules to each Unity version by clicking on the cog and selecting Add Modules. Modules are additional tools you can install when making games for a particular platform. For example, you could install the iOS build support module when making games for iPhones, or WebGL build support to publish your games online. Remember that each module requires some space, so check if you have enough left before installing anything. This is also where you uninstall older versions of Unity once you upgrade to a newer version. Just make sure you don't have any projects using the older version you want to uninstall, otherwise you might have to re-download an older version to work on those projects. You can check which Unity version a project uses on the Projects tab under the Editor version. By the way, the Unity editor is just a tool you use to build games, like Photoshop is used to edit images. The Unity game engine is the term used to refer to the Unity editor and all its associated tools, the same way Adobe refers to all the tools together. Thought I'd mention that so you don't get confused when I talk about the Unity editor instead of the Unity game engine. The Learn tab is where you'll find tutorials, courses, and other helpful learning materials created by Unity to help you get started with making games. You can download them or review them on the Unity Learn website. I'd recommend checking them out to sharpen your game development skills even further. There's plenty of material and learning paths, so I'm sure you'll find something useful. The Community tab is where you'll find updates on Unity events, announcements of new features and improvements, and forums to discuss game development with others, so you can always check in every once in a while to stay up to date. The Downloads button at the bottom of the sidebar reveals whatever items you're currently downloading, if you have any, and the current Unity Hub version you have installed is displayed at the top left above the sidebar. If you want to add an existing project, you can click on the arrow next to Add and select Add Project from Disk, but for this demo, you'll be creating a new project, so click the New Project button. The next screen shows all the types of projects you can create. The sidebar groups them up into different categories. The middle section lists all the available ones and the ones you can download, and the right section gives you a brief overview of what the template is about. Feel free to browse them to see what features each one offers, how much space they take, all packages pre-installed in the template, and what have you. If you want to see what a finished project looks like, you can select one from the Samples category. You'll be using the Universal 3D template for this demo, so go ahead and select that. This template is optimized for creating 2D and 3D games for different pipelines. I plan on creating a separate video explaining the different pipelines, so remember to subscribe if you want to see those in the future. For now, just follow along with me. Name your project in the section to the right and choose your preferred location to save it. You can leave the save location the way it is, but if you want to save it elsewhere, go ahead and change it. The Unity organization doesn't play a big role in this project, so choose whichever option is in the drop-down. You won't need to use Unity Cloud or Unity version control, so you can leave those boxes unchecked. Finally, click the Create Project button. Give it a minute or two to install all the packages. Once the project is ready, you can close the Unity Hub since you're done with it. But while we wait, if you'd like exclusive game dev content such as this game I built in 48 hours, you can access it by becoming a patron over on patreon.com/heightabovesealevel. Each Patreon member now also gets ad-free versions of these YouTube videos and a custom theme for Visual Studio made by yours truly. These are just some of the benefits, so I hope to see you there on patreon.com/heightabovesealevel, and thank you to all of you who do become members. What you're now viewing is the Unity editor. Don't worry if it looks overwhelming at first glance. I'm going to show you what all these windows and tabs do. If you've ever used any creative software like Photoshop, Figma, or DaVinci Resolve, you'll find it a bit easier working in the Unity editor since you're familiar with dealing with many windows and complex user interfaces. But if you're new, there's still room to learn and you'll get there eventually. This demo is for Unity on Windows, but aside from some of the keyboard shortcuts that might use Command instead of Control on Mac, everything should work the same regardless of which platform you're on. Every window you see here can be resized, moved around, turned into a floating window, and closed or opened according to your needs. Let's start with the window that's almost always front and center, the scene view. This is where you'll do most, if not all, of your world building, animation, testing changes, lighting, and many other things. Click on the window's name and a blue bar will appear above it, letting you know it's the currently active one. This is important because certain keyboard shortcuts require the scene view window to be active to execute. There are 3 buttons to the far right of this tab, so go ahead and click that and select Maximize tab. Let's look at navigation in the scene view. If you press the mouse wheel button and move the mouse around, you'll drag the screen left, right, up or down in the scene view. Scrolling up on the mouse wheel zooms in, while scrolling down zooms out. If you right-click the mouse and move it, you look around the scene view as if you were standing in place and turning your head. One cool thing to note is that even if the cursor goes out of the screen, for example to the left, it'll show up again on the right side, so you can keep moving it in one direction as long as your desk has enough space to do so. The same goes for up and down, and this applies to a couple of other things in the Unity editor, such as adjusting a large slider in one direction. Alternatively, if you don't like using the mouse wheel to zoom in and out, you can hold down Alt, right-click the mouse, and then drag left and right. Similarly, you can hold down Control, Alt, left-click the mouse, and then move it around to drag the screen in the scene view instead of pressing down the mouse wheel. You can also walk around the scene view as if you were playing a first-person game by pressing the arrow keys to move left, right, forward, and backward. If you want the full FPS movement while in the scene view, hold down the right mouse button and move around with W, A, S, and D. Hold down Shift to move faster, and you can move up and down with E and Q respectively. Click on the 3 dots again and select Maximize to restore the scene view to its original size. To the left of the scene view, you have a list of items. This window is called the Hierarchy window, which stores everything you have in the scene. You already have a couple of things automatically inserted for you when you created the project, so click the main camera to see what happens. The scene view now shows some lines representing the camera's view frustum. You can zoom out a bit more to see it more clearly. If the grid is in the way, click the grid icon at the top of the scene view to toggle it on and off. You might also see a red, green, and blue arrow. If not, click on the 4-sided arrow icon in the floating tools bar. This is one of the many gizmos Unity has. Gizmos are visual representations of tools in the scene view. Some are interactive, while others are there for informational purposes only. The one you're looking at is the Move Tool gizmo that's used to move things around on either the X, Y, or Z axis. If you click the other tools in the floating tools bar, you'll see a different gizmo for each one in the scene view. Hovering over each tool tells you what the tool does. For now, go back to the Move tool. If you click on one of the arrows and drag, you'll move the camera in the direction the arrow is pointing. Over in the Hierarchy window, you'll notice a little star next to the sample scene item. This means you haven't saved changes because you moved the camera around, so to save your changes, you can go to the File tab at the top left and select Save. You can also use the convenient shortcut Ctrl+S. Sample scene is just the name of the scene, and you can change this anytime to something like level 1 or boss fight, depending on your needs. Every item you add to the scene becomes a child of this scene item. Speaking of which, I've been calling everything in the hierarchy items, but the actual name for them is game objects. A game object can be anything in the scene, from 3D models, cameras, textures, 2D images, commonly referred to as sprites, and so on. If it's in the scene view, it's most likely a game object. Let's add a couple more game objects to make things a little more interesting. To add a game object, right-click any empty area in the hierarchy window, select 3D object, then click plane. You can also add a 3D object by clicking on Game Object at the top left of the screen, selecting 3D object, then clicking on Plane. Go ahead and add a cube and a sphere using the same method, and those game objects will be added to the hierarchy too. You've probably noticed the window to the right changing, so let's talk about that for a bit. That's the inspector window. It tells you more about the game object, including any modifications you've made, the game object's current position in the game world, and all the components attached to the selected game object. A component is a tool attached to a game object that changes its behavior, for example, by changing its shape, position, color, physics interaction, and more. Look at the component at the top of the inspector window. This is the transform component every game object has that tells you its position in X, Y, and Z coordinates, the direction it's facing or its rotation, and its scale according to the 3 axes. Left-click on the red arrow in the scene view and drag it around while observing the component. Note how the value in the X input changes. The red arrow is for moving along the X-axis, left and right. Do the same thing with the green arrow. The value in the Y input changes because the green arrow moves the game object along the Y axis, up and down. Finally, do the same thing with the blue arrow. The value in the Z input changes because the blue arrow moves the game object along the Z axis, in and out. All the directions will change depending on how you're looking at the game object, so keep that in mind. You can also move the game object by placing the cursor on the left edge of each input box and dragging left and right, or manually typing in a number. You can perform similar actions with other tools. For example, click the circular icon in the floating toolbar to switch to rotations. Left-click the green line and drag left and right while observing the inspector. The Y input of the rotation changes because you're rotating the game object on the Y axis. Think of this as sticking a vertical rod through the bottom of the game object and then spinning it like a shish kebab. You can do the same for the red and blue lines, and the values in the inspector will change accordingly. Again, you can also make the changes in the inspector and they'll show in the scene view. Try playing around with the other tools in the floating toolbar while observing the inspector to see what kind of interesting things you can do. If you want to reset everything, you can easily do so by left-clicking the 3 dots next to the transform component and choosing Reset. Aside from the game objects you just added, the project started with a directional light game object to light up the game world so you can see everything. This is the sun in the scene view, and a main camera to render everything. If you click on the check mark at the top of the inspector window of the directional light game object, you'll enable and disable it. The same goes for other game objects as well. Don't worry too much about the other components attached to some of these game objects for now. You learn about them the more you use the Unity editor. This demo is mostly meant to help familiarize yourself with where everything is and what the most important things you need to know first are. The global illumination object is also used for lighting, but just leave that the way it is for now. Once you've built everything the way you like and are ready to play test it, you can do so in the game view. The game view shows you how the game will look to the player and is where you'll test all your user face interactions, button presses, animations, audio, and so on. To switch to the game view, click the Game tab next to the Scene tab. Depending on where you place the earlier game objects, you might see them all in view, too close or too far from the camera, or you might not see them at all. To fix this, switch back to the Scene view and make sure the main camera is selected in the hierarchy. If you zoom out far enough, you'll see the camera's view frustum, which determines what the player can see and what they can't. There's also a little preview at the bottom right of the Scene view to give you an idea of what the camera can currently see. You can move the camera around so everything is in view, or move the game objects around so everything is in frame. When everything looks good in the camera preview, switch back to the game view to see the final output. Like the Scene view, you can maximize the game view by clicking the 3 dots. The same applies to all the other windows too. To play the simple game you just created, press the play button, the little triangle, above the game view, but alas, nothing happens because you haven't added any music, code, or other assets to your project. However, there's something you can do if you want to see some action. Exit play mode by pressing the play button again and then select the cube in the hierarchy window. In the inspector window, click the button at the bottom that says Add Component. This brings up a list of all the components you can add to this game object, but the one you want is called a rigid body, so go ahead and start typing the word rigid body and you'll see 2 options. A 2D version with the words 2D attached to it and a regular 3D version. Select the 3D version and you'll see a new rigid body component added in the inspector window. Rigid bodies are used to work with physics, and as you probably can tell by its inputs such as mass and angular drag, you can affect how gravity acts on this game object. I plan on covering the most essential components later, so please subscribe and turn on notifications if you're interested in learning about those. In the Scene view, make sure the cube is raised a fair distance over the plane. Switch back to the game view, press play, and voila! Your cube falls as if gravity is pulling it down and collides with the plane because both game objects have collider components. You can even adjust the rotation or move the sphere below it for some more interesting interactions. The sphere doesn't fall because it doesn't have a rigid body, but you can add one to it for the same effect. Go ahead and try it. Feel free to play around with inputs in the rigid body components such as changing the mass or drag to see what happens. You're slowly becoming a game developer, guys. Let's make things a little prettier by changing the colors of the game objects in the scene. You can do so using materials. Materials are used to change the appearance of a game object's surface, so you'll create one in the window at the bottom called the project window. The project window stores all your files such as audio clips, materials, 3D models, animation clips, textures, and anything else that's part of the game you're making. This might sound like the hierarchy window, but the difference is the project window stores everything in your project, including the assets you're not currently using in the scene, while the hierarchy window only shows the game objects you added to the scene view. Speaking of assets, all your assets are stored inside the assets folder, and you can see it in the sidebar in the project window. Anything you add to a game project that isn't a development tool can be considered an asset. Development tools make building the game easier, while assets are all the things in the game itself. These development tools are added to the project through packages, and you can find them all in the packages folder. The reason it took a couple of minutes to create the project in the beginning is that the necessary packages were being installed for you. But back to materials. To create one, switch to the assets folder, right-click an empty area, choose Create, and then select Material. You can name it whatever color you plan on making the cube, but I'll name it red because that's the color I'll be using. Over in the inspector, you'll see an input named Base Map with a white stripe next to it. Click it to open up a color wheel and select the color you want. As you adjust the color slider, the materials icon at the top of the inspector and in the project window will adapt to reflect your changes. You can also manually adjust the red, green, and blue channels if you prefer that approach, or input a hexadecimal value. That's the color value that usually starts with a hashtag, but the hashtag is excluded from this input. You can apply the material in two ways. The easiest way is to left-click and drag it from the project window onto the cube. As you pass over the plane and sphere, you'll notice the material being applied to them as well. If you made a mistake and added the material to the wrong game object, you can undo this by pressing Ctrl and Z at the same time. If you want to redo what you just did, you can do so by pressing Ctrl and Y at the same time. Create another material the same way you've just done called purple. You'll apply this material to a game object using the second method. Click on the sphere and, over in the inspector, you'll see a component called Mesh Renderer with a Materials dropdown. Click on this dropdown to expand it, and then drag and drop your recent material into the element 0 input. The sphere in the scene view will now be updated with the new material. If you now switch to the game view and press play, the game objects will have the materials applied. As a simple test, add a material to the plane. You can play around with each material's smoothness or metallic map to change its appearance. The Unity Asset Store has numerous free and paid materials you can download and apply to your game objects, so remember to check them out to see what kinds of shenanigans you can get up to. Another asset you can add is a script asset to store all your code. You're relying on physics alone to see some action right now, so let's look at how you can manipulate a few things with code. Before doing so, make sure Visual Studio is installed on your computer. This should have been installed along with Unity, but if it's not for some reason, you can install it from the Unity Hub as a module or the Visual Studio website. To create a script, right-click an empty area in the project window, select Create, and then choose C# script. Give it the name sample script with the first letter of each word capitalized. Over in the inspector, you'll see a short preview of what's inside the script. Go ahead and double-click the script to open it in Visual Studio. I know this looks overwhelming, but for this demo, you'll just write some simple code to spin the cube. If you'd like to learn about Visual Studio before moving forward, which wouldn't be such a bad thing, I have a video breaking it down so beginners like you can feel more comfortable using it. I've linked that to the top right of your screen. Unity also uses the C# programming language, so if you'd like to learn how to use it, I also have a playlist explaining it to beginners linked to the top right of your screen. What you have in front of you in Visual Studio is a class called sample script. Classes in C# are containers that store related code and work with other classes to make video game applications. They're the building blocks of each game's codebase. Inside this class, you have two methods, start and update. Methods perform actions in the game. If you wanted your player character to jump when you press a button, you'd create a method called jump with some code inside it. If you wanted them to shoot their gun, you'd have a method called shoot, and so on. As the name suggests, the code in the start method is executed when the game starts. In other words, when you press the play button in the game view. The code in the update method is executed during every frame when the game is already playing, so if you have a game running at 120 frames per second, the code is executed 120 times per second. Let's see all this in action. Write the following between the curly braces of the start method. Debug, period, log, and inside the parentheses, type the message hello from Visual Studio surrounded by double quotes, then finish up with a semicolon. The semicolon at the end is kind of important, so don't forget to add it, otherwise you'll see a red squiggly line meaning there's an error in your code. Remember to save as well by pressing Ctrl and S at the same time. Back in the Unity editor, create a new cube game object like you did before. For a script to work in Unity, it needs to be attached to a game object, so this new cube will be the one you attach it to. You can also rename it in the hierarchy to tell it apart from the other cube. With the cube selected, left-click on the sample script, drag it, and drop it at the bottom of the inspector. A new script component has now been added to the cube. If you ever wanted to attach a script to a game object without having to drag it from the project window to the inspector, you can click the Add Component button, type Script, click New Script, give it a name, then click Create and Add at the bottom. You can also minimize all the other components by clicking the 3 vertical dots at the top of the inspector and selecting Collapse All Components if you don't need all of them open. When you now press the play button, you'll see the message you wrote in the code at the bottom of the screen and the status bar. All your logged messages, warnings, and errors are displayed on the console, which is like a notification board for all the things going on in your game. If you want to open the console window to see all your messages, you can either left-click the status bar showing the most recent log message or left-click the console tab next to the project tab. Go ahead and log another message in the sample script to see what happens. You now have 2 messages in the console. It's always a good idea to keep an eye on this when making your game to stay on top of any warnings or errors. One more thing before you write code to make the cube spin. Move the messages to the update method and then press the play button while observing the console. The messages are logged once every frame. Let's now look at how you can rotate the cube using code. Back in Visual Studio, delete the debug statements, then type gameObject to connect to the gameObject the script is attached to so you can manipulate it. Next, type a period to access all its properties and the methods you can apply. Type transform to access the transform component. Remember that? It's the component that controls where the cube is positioned, how it's rotated, and its scale. Now that you have this component, you'll type another period to access its properties and methods. The method you want is called rotate, so type that followed by an opening and closing parentheses, then a semicolon. Inside the parentheses, you'll specify which axis you want to rotate the cube on. Type a 0, meaning you want no rotation on the x-axis, a 1, meaning you want to rotate the cube 1 degree on the y-axis every frame, and then another 0 to mean you want no rotation on the z-axis. Save this, switch back to Unity, and press play to see the magic. Try moving the 1 around to see how this affects the rotation. You can even have 3 different numbers. Go ahead and play around with the numbers to see what happens. I'm sure you'll at least be entertained by the results. These are the kinds of changes game developers make at big companies like Blizzard, Activision, or Ubisoft when trying to balance games. If a weapon is doing too much damage, for example, they'll change a number in the code like you've just done to reduce it. The same goes for player speed, movement penalties, magazine sizes, and more. Those games obviously have many more moving parts, but at their core, this is how they're tweaked to achieve the desired result. So I hope you feel good having the power to change a game to your liking like you've always dreamed of, rather than living with balance changes you absolutely can't stand. Feel free to duplicate the cube a couple of times to liven up the scene by pressing Ctrl and D at the same time on the cube in the hierarchy window. This is just the beginning of your game dev journey, and the more you tinker with Unity, read the documentation, and make more simple games, the better you'll get at it. Before I let you go, I'd like to show you what a simple game looks like during development. I call this game Bootleg Fruit Ninja. Here's the gameplay. If you'd like to play this game on your browser, I published it on Unity Play, so I'll leave a link in the description. Here's what my assets folder looks like. The bigger your game gets, the more organized you'll need to be, so it's best to arrange scripts, game objects, materials, and what have you into folders as soon as possible. You'll also end up using more features Unity has to offer, such as animations, audio, or lighting, so you'll need to add their respective windows in such a way that everything is easy to find. Brief recap of everything as we wrap up. The scene view window is where you do most of your world building, adding and removing 3D models, testing, etc. The game view window is where you preview how your final game looks and plays by pressing the play button. The hierarchy window lists all the game objects in the scene. The inspector window gives you more information about a selected game object or asset by exposing all the attached components. The project window is where all the project's assets and packages are stored, and the console window is where you'll find error messages, warnings, and logged messages. Unity has many more windows and features, but these are the most essential ones you should know first to get started. That's all I had for you guys. If you enjoyed the video and learned something new, please give it a thumbs up and subscribe for more just like it. Leave your questions in the comment section below and I'll get to them as soon as I can. Again, if you'd like to support the channel and receive a custom Visual Studio theme, you can do so on patreon.com/heightabovesealevel. There's a Discord server if you prefer chatting over there, link in the description below. And I have a Twitch channel if you enjoy live interactive experiences, more over on twitch.tv/avatarvic. Unity has so much more to offer, and I plan on making more of these videos, but your feedback through comments and liking this video is the only way I can know if I should keep making them, so please let me know. Thank you so much for watching, and as always, from me to you, deuces.